Assalamualaikum warahmatullahi wabarakatuh, and very good morning to my panel, Dr. RAHMAT, TALIB, and Dr. YEE SEE KHEE. My name is Mohamad Akhiruddin IBRAHIM, GE 1048, and my project is IoT-based water quality monitoring system for lake water. Here are the content of my presentation. The first one is my project diagram, problem statement, objective, scope, methodology, preliminary result, conclusion, and lastly the future work. Water is required proper care to bring the best quality of water. It is because the water is easily contaminated with microorganisms, toxic, and human waste. Some of the water contamination is unable to see with naked eyes. The water contains pH level. As we know, the average pH level needed for the water that is safe for human consumption is around 6.5 until 8.5 value. Other than that, it is quite poisonous for human to take. So I came up with a project that has IoT-based water quality monitoring system for lake water that will consistently monitor the water pH value. This concept is appealing, but there are several constraints that must be addressed. The first one is the people itself don't actually care about the pH of the water because they only just want to use it. The project likely used by a short amount of time. The period pH sensor could only collect water quality data in one area only because the pH sensor is unable to move on its own. And finally, the maintenance and the value of the product component are quite costly. So here are some of the objectives of my project. The first objective is I want to develop an independent water monitoring system that can move on command freely. My second objective is I want to monitor the pH value of the lake water. The third is to improve the AZIZAN design. And lastly is to create unlimited range control and notification for the project. My scope of project is the first one is to receive and send data. The MCU, the ASP32 is connected to the Arduino Uno through network and Wi-Fi. Blink application system, they are capable of handling operation in stable network coverage. The Blink application provide input to the IoT system, which then enable the microcontroller to move the board by sending commands to it. The ESP32 is a tool for data processing the lake water pH level to monitor water quality in addition to controlling board movement. The board design concept is accordance with the design requirement to preserve stability and durability while being tested in various locations with various environmental conditions. And lastly, when the data is received, it is updated all the time. For my methodology to obtain the objective, the first step is I run a background study about the project, and second step is read the literature review that is related to the project, and the third is the listing of the component, where I selected some of the component that will be applied in the project. The second page of this project is development of simulation system, where the simulation is created in the Proteus X software in order to prove that the pH value can be measured by using the voltage in the Proteus, and then record the development of the output data. For the third phase of the achieving the objective is development of the hardware that will be happen on the next semester for PSM 2. The first step is development of circuit and calibration. In this step, we also have to create the body frame of the board. The second is transfer data from the trial process of transferring data from the MCU to Blink application. And the third is to record and monitoring the response data. For the project process flowchart, I have separated the flowchart in two parts, where the first will explain in detail about the board controlling system, and the second part will explain in detail about the pH monitoring system. It starts when the Wi-Fi is connected to the mobile phone. The ESP32 will link with Blink, and then it will give command to servo motor or motor driver.
The servo motor will control whether it want to go left or right, and the motor driver have function that will give command whether to go move forward and backward, and also to control the speed of the boat. If the boat we want to move forward, then we choose the button to move forward. If no, we insert another input. If you want to go backward, then we choose to go backward. If no, then we proceed with the other command. If you want to go to left, we choose left, and if you want to go to right, we choose right. For the second part, it starts with the initialize the software serial on both UNO and NodeMCU SP32. The send data will entry from NodeMCU to UNO. The pH sensor module will read and receive the analog data. The analog data will convert to digital into the Arduino UNO. The data processing to calculate the value of the focus area. If the pH sensor detect the lead water, it will proceed with the next step. If no, then it will read again from the pH sensor module that will receive the analog data. If we gain the data, we can see that the water is whether it's acid or neutral or alkali. Then the data is sent to the Blink application. It will display notification on the mobile phone. For my project preliminary result, I have separated in 3 different parts. The first one is SketchUp online. The second is the experiment result on litmus paper, and the third is simulation on Proteus software. The SketchUp online is about the rough boat design, where we can see that the boat is square. It is because it will become more stable and have a strong durability. The measurement is not quite the same because it has not taken the measurement of the component. For the experiment result, it is on to test the pH value assistant. I use the litmus paper, where we can see in the picture. The first picture is a lemon, where the lemon water is change the litmus paper from red to from blue to red, which means that the lemon water is acidic. The second picture is mineral water, where the litmus paper does not change color. The blue and red litmus paper stay the same. And the third picture is baking soda powder, where we can see the red litmus paper change to blue. And finally is the simulation on Proteus 8. We can see here is the circuit connection of the Proteus 8, where the data will be displayed on the LCD. We can change the LCD light using the potentiometer at RV1, and we can change the pH value of the data at RV2. Last but not least, clean water is extremely important, because human will die in 3 days if they don't get any waters. The initial phase of the development of the IoT-based remote controlling lake water quality device notification system will be finished by the end of this semester. Additionally, pH reading is essential to acquire another parameter for pH value in order to monitor water quality. The measurement then can be read via dashboard for this Blink mobile application, which will also develop for this semester. For the first step of my future work, the first thing I will do is the development of the body frame of the boat and the control system of the water quality monitoring. The second is I will replace the LCD on the Proteus with the Blink application interface. And lastly is I will improve the old system. So that's all from me. Thank you.